to MZmine for mass spectrometry and data processing. And of course, parts like I didn't do this whole presentation on my own. Like some of the slides were lifted from some other people. That's why you will also like see some of the same slides I used yesterday. So first of all, mass spectrometry, I think it's really great because you can use it in such a variety of fields. And one of the fields that I'm using it in, and a lot of you are probably using it in, is the field of metabolomics. And for example, it's for analyzing plants, analyzing the microbiome. Some people even use it in space to analyze, I don't know, the topology on Mars or something. It's used in food analysis and medical analysis. And what's so great about mass spectrometry is that you have a lot of different setups that you can use for different applications. So, for example, you can use a GC, you can use electron ionization, you can use LC, you can use Helix, you can use multi-imaging, and with the new additions, you can also use it with ion mobility spectrometry, which is something I did a lot of work with. And one challenge and also one common thing in mass spectrometry is that we acquire mass spectra, and then in the end, we try to make sense of the individual spectra. And since we have so much data with high resolution mass spectrometers, we have to use like some software, for example, to extract the ion chromatograms, because otherwise it's just like way too much work to do manually. And one thing basically every mass spectrometers have in common are these spectra, because on multi-imaging, you basically acquire one spectra for one pixel, and in the end, you can extract like ion images, and which is also a thing that you can do in MZmine. So if anybody of you does multi-imaging as well, maybe MZmine is the right software for you. And one thing that is really important is that for the raw data, it can be in profile mode, which basically explain or is shown with continuous data across every peak shape, or it can be already centroided, which you can see here, where you just have like basically one X and one Y coordinate, so an MZ and an intensity and no distribution. And one thing that really complicates the spectra is the common or like the common occurrence of in-source fragments and isotope patterns. So as you can see here, it really adds a lot of redundancy to the data, because on the left side here, we have the isotopic pattern, and all these like the main information that we're looking for is maybe this small peak because it's a monoisotopic mass, but all the other signals belong to the same molecule. So during the processing, we really want to scrunch that up and reduce it to the monoisotopic mass of the feature. And the same goes for the in-source fragments. So for example, it can tell you something about the structure, but on first look, it will just complicate your data. So it's ideal if we can make sense of what ion adduct it is. So if it's an N+H, if it's an N+sodium, or if it's a neutral loss of a water atom. And one thing that really helps with structure elucidation is the acquisition of a Tandem mass spectra, which basically works in a way that we first filter out one selected ion and throw away the rest, which is usually done by quadrupoles, as Allegra mentioned yesterday. And this ion is then fragmented, and you get then the intensity of the individual fragment ions in your MS2 spectra or MS-MS spectra. And from that, you can probably tell if you have a structure that is, that you think it could be, then you can maybe assign the fragment ions. And I know this slide was already shown yesterday, but who of you, or like, who can tell me which is the better HPLC MS2 method? Do you really want a lot of MS2 spectra all the time? Sorry? Yeah, A is better. Why is A better? Yeah. So what's really important here is that we want to get meaningful MS2 spectra, and we don't want to get during our acquisition MS2s of the same compound all the time, which may just be plasticizers. So, and you can also do this in MZmine. I can show you later, like how you can look into what you actually fragmented in a nice way. And so first of all, who of you has already used MZmine for his data processing? And if you still use MZmine 2, leave your hands up. No one, oh, 2 people still use it. 3 people still use MZmine 2. Man. You should change. And I hope that today I can tell you why you should change, and you can see that MZmine 3 is just way better. And who of you uses other tools than MZmine? So for example, MS-Dial or XCMS or so. Okay, I hope that you in the end see some advantages of MZmine. Maybe XCMS or MS-Dial is the better tool for you. So maybe do you do a lot of data independent analysis if you use MS-Dial? Yes and no? Yeah. So probably for data independent, we have like some tools in MZmine, but maybe MS-Dial might still be the better tool. But if you want to test it, we are free for feedback, or we are open for feedback. So if you want to test our DIA workflow and it works, please tell us. If it doesn't work, please also tell us. So about the history of MZmine, it was first introduced as a MASO in 2004. By Mikko Katayama, which was later then changed to the name of MZmine in 2006. And in 2010, Tomasz Pluskal, he totally reworked the software, and then it became MZmine 2. And in 2022, we were able to release MZmine 3. And over that time, MZmine, the development community has really picked it up. And a lot of people have contributed to the code. We also use the Google Summer of Code to get some new contributors. So if any one of you is a PI or trying to become a PI or a postdoc, or you know a student that would like to, or you have a project and you have a student, or you know a student that would like to work on data processing software, please feel free to reach out to us. We also have like always ideas for new projects. So if you know someone that can code or is a chemist with like a lot of interest in coding, please let us know. And so to underline what I just said, you can see here like the lines of code written that we used for MZmine by now, and then you can see here in MZmine 2, there or since MZmine 2, like a lot of additional tools have been added, which led to the release of MZmine 3. And by now, we even did a lot more changes to make the software even better. And one thing that I would like to really highlight here is that MZmine is really a community effort, and we don't develop MZmine alone. So a lot of institutions have contributed code, and it's really a community project. So if you shouldn't be scared if you have like a really nice idea or so, we can help you implement it. If you don't know how to code, we can probably also make something work if you have a student or so. I'm just saying we can't do everything, like every good idea. It's not possible for us to implement, but we're always open for new contributions. And one thing that I would like to stress is MZmine is not a black box. You don't put your raw data in, and you don't get out Nature papers and Nobel Prizes. But what MZmine used to be is more like the Swiss Army knife. So it's a tool for everything. You can do everything you want with it, but you have to, or you had to know how to like really make use of it. And which was also a problem why MZmine was maybe a bit complicated for new users to get into. And this is something that we also addressed with MZmine 3. We try to make it more usable and more user-friendly with the MZmine Wizard, and which is also something that we are going to use today. And so what MZmine is actually trying to do is we use our raw spectra, and be it from GCMS, LCMS, Helix MS, MultiMS, whatever you throw at it. We are trying to apply some magic and extract a feature table that you can make sense of. So we are trying to extract the mass to charge ratios, the retention times, the peak shape, tell you, okay, it might be this ion, try to identify it. And yeah, same slide. So looking at the raw data, so because I think it's really important for if you want to process the data, it's really important to know what the data actually looks like. And looking at the regular LCMS data set, we basically have a three-dimensional data space. We have the retention time axis, we have the mass to charge ratio axis, and we also have the intensity. And from this data, if we look at this at the data this way, we can see the individual mass spectra. So our mass spectrometer is constantly acquiring mass spectra, looking at the data. And if we look at it in the other direction, we can extract the ion chromatograms. And from these ion chromatograms later, we want to basically just know, okay, the peak starts here and ends there, and this is our feature. And how it works in MZmine, this is a really like broken down workflow. You first import your data if the data is profile. Really a peak associated with every mass to charge ratio. Then the data is centroided. And then we filter out every signal that is just electronical noise or below a certain threshold. Then chromatograms are built, so just the intensity over the retention time. And these have then to be resolved into individual features because those are basically not the same compound. Those are individual compounds that are being separated by the HPLC column. And we want to address every compound in individually. And across multiple samples, we then align the compounds together. And so you, for example, if you have a large study, you can you directly see, okay, in this sample, this compound is like really intense, or it is less intense. And every of these individual steps in MZmine is what we call a processing step or a module, and you can configure everything. But with the MZmine with MZmine 3, then we also added the ion mobility spectrometry, which is an extra processing step or an extra module. And then you can do a lot of downstream processing. And the thing is, it's basically, if you look at the full workflow, which might look like this, it has a lot of steps. And maybe because, I don't know if you tried MZmine before and you saw, okay, man, this is way too much stuff to configure. It might be a bit complicated, which is why we introduced the MZmine Wizard to really get rid of a lot of the redundancy that we had in the data, because basically in every step you had to define an MZ tolerance, but it was the same MZ tolerance all the time. So we really try to simplify that. And another great thing is with MZmine, we are comparing to MZmine 2, we are a lot faster. You can process a lot more data sets on a lot less system memory. And I hope everybody has at least like 8 or 16 gigabytes of RAM. If you don't, then we just take a small subset of the data because we also have all the results uploaded. So you don't have to do the full data set. Maybe if your laptop crashes or MZmine crashes, which might very well be, then we can just download the results in the end for the next sessions. So that shouldn't be a problem. And after the MZmine workflow, you get these large feature tables that give you a lot of information, and that we can then use in the downstream tools such as Zerios, NGNPS, and so on for statistical analysis in the following sessions. And just like looking at some video on MZmine, you can explore the raw data. You can look at the base peak chromatograms. You can check, okay, at this time, how did my spectra look like? You can investigate some data manually. So you can do some like quick quality control or so. And if you really want to get into the processing, we have the processing wizard, which basically plugs together like your mass spectrometry system does in your lab. So for example, you can select, okay, I used HPLC, I used GC, and you get like presets for everything right away. You can say, okay, I used the MALDI, I used the TIMS, and this way you get a lot of presets that might make sense for your data. I'm not saying it will be perfect, but you will already get like some results. And from there, we recommend to optimize the settings for your specific acquisition, for your specific method. And for that, it's really nice that you can have individual presets. For example, you can say, okay, I don't know, this data set was acquired with this mass spectrometer, and I can just like save a preset, and I can also load a preset. For example, if you have a C18, I don't know, 30-minute gradient, you can say, okay, for this HPLC method, my peaks are always this wide. So I can say, okay, I don't need to optimize, like I optimize it once, but I don't need to optimize again. And then you can just like load the data in. Yeah, one thing I would like to stress for annotating your compounds, there are a lot of public spectral libraries, and they also work with MZmine. So if you are trying to get some spectral library matches, you can freely download the GNPS library, you can download the Mass Bank of North America library and the Mass Bank EU library. Some of them are free to use, but not free to download. And some like NIST are, not, you have to buy them basically. But if you're looking for the MZmine compatible format of the download, I listed it over here. So most of the time it's a JSON format, except for the Mass Bank EU. And if you want to make your data available for example, a paper or a project that you're working on with some collaborators, these are like some of the most used repositories where you can deposit your data set. And after you published, you can make it publicly available so people can still use the data and maybe find some compounds of their own in your data and make more sense of it, which really helps in a lot of studies. So, do you have any questions so far? Otherwise, we can directly get into the hands-on. No? Yeah? So that would be a lot of manual analysis. So there are like some tools in MZmine that you can use for that, but basically MZmine is more tailored towards like automated data processing and not like manual structure annotation or something like that. So yeah, you can export all the spectra. You can then use it in any other software, or you can I don't know, find spectra or like compounds that have like I know this specific neutral loss or so, but it's not like measuring manually. But I think that's probably something that we will maybe add in the future. No promises on when, but yeah, might be a good point. So talking briefly about the data set. The data set we are going to use is dissolved organic matter. Basically what was Daniel, right? Yeah, what Daniel did to get a data set was sample seawater in a lot of different locations close to the I think it was La Jolla. Sorry. Oh yeah, San Diego coastline. Nice. And for every data set, it was acquired, like 2018 data that we're going to use was sampled after a heavy rainfall. So we will basically look at the shift in the chemotype of the data after a lot of xenobiotics have been flooded into the sea. Yeah, anything else that's important? Okay. If you have any further questions for the data, ask Daniel when he's here. So then let's go into the dataset processing. So I hope all of you have downloaded MZmine, and I hope it works for you. So it's still sharing, yeah. So I'm just gonna run the MZmine .exe. And yeah, if you get this message on Windows, you click on more information and you say, yeah, run anyway. And then it might take a couple of seconds to open the window. Everybody so far, everybody have MZmine open?
I know, guys, that you have problems back there with the electricity. We have an issue. There's one computer that is giving a shortcut to the extensions. And it's going to be so if we try to figure it out right now, it will take a while. And I don't want to interrupt Steffen more longer. So during the coffee break, we will try to figure out who's the computer who is creating the shortcut and is shutting down completely the back electricity. It doesn't matter if I change it to another wall, because if that computer plugs again, it will shut down also the walls in the sides. So please try to unplug all the computers who are connected to the extension in the back, and let's try to see if this goes back or not. Okay. I'm sorry for that, but it's out of my hands. We need to figure out which is the computer who is creating the shortcuts.
Yeah, okay. No worries. Okay, so if you have MZmine opened, then we can, yeah, first of all, look at our data. So I'm just gonna pull up the data set. And, oops, not this one. So I will start in the samples folder. You can basically pick any file you want, but I will pick this specific one here. So the 19_A, because this is for me something I can show you some stuff on. So to import the data, you can do multiple things. I just recommend to like drag and drop the file into the left side of the MZmine window, and then it will automatically import the data. So I'm just gonna wait a few seconds. So what I did was I just, yeah, grabbed the data, drag and dropped it into here, and then the data shows up in the MS Data Files tab. Everybody has the data imported? Not yet? Okay, then we wait shortly. Do you have any problem or? Oh, okay. Yeah. Okay.
So the person from electricity, the persons from the house that take care of the electricity, they are coming right now. We need to find a strategy. There's one computer. It seems one computer, when this computer plugs in, is completely making a shortcut and shutting down the electricity in the back of the room. So we need what we think is would be the best right now is that all of you unplugged, so he's able to switch